Hello, the word probability is not new to any one of you. You are familiar of using the word probability to possibly discuss the weather. What's the probability that it's going to rain today? Or what's the probability that Indian cricket team is going to win a particular match? In maths, we've been talking about probability and the questions related usually were like, what's the probability of getting a sum of 7 when a pair of dice is rolled? What's going to change is, if the question says what's the probability of getting a sum of 7 given that one die shows a 5. We know that when we roll a pair of dice, the total possible outcomes are 36. What happens in the second situation? We are given that one die shows a 5. How many possible outcomes result out of that? 11. 11 ordered pairs of the kind 1, 5, 2, 5, 3, 5, etc. are the one which we know possibly would have happened. So, the total possible outcome instead of 36 have now reduced to 11. Out of these, which of the few, in this case only 2, satisfy the condition that the sum is 7. So, if I want to talk about the probability, then in the first case the probability of getting sum of 7 is 6 by 36, that is same as 1 by 6. Whereas, in the second case the probability of getting a sum of 7 given that one die shows a 5 reduces to 2 by 11. So, now instead of a sample space of 36, our sample space has shrunk to 11 outcomes, and out of those 11 there are 2 favorable for getting a sum of 7. And this is what we are going to be talking about as conditional probability. We were given a condition that the die, one of the die shows 5, and then we were finding the probability of getting a sum of 7. Let us illustrate this further by taking another example. Suppose I consider the sample space of 3 fair coins tossed. We know that there are 8 possible outcomes. Let us describe event E to be at least 2 heads appear and F to be the event that first coin shows tail. Then you can always represent the 2 events in the roster form. Now, let us look at the situation where E is known to have occurred. We want to find the probability of occurrence of F. E was nothing but at least 2 heads appear. That is, these 4 possible outcomes are known to have occurred, or one of them at least would have been known to have occurred. So, our now sample space out of which we are going to look at the probability for the occurrence of F happens to be this set. What we know of F was the event of first coin shows a tail. Out of these 4 which have been known to have occurred, there is only one case where you have the condition of F being satisfied, that is T H H. And so, if one asks you what is the probability of F given that E has occurred, then it is nothing but 1 out of 4. So, that is what the conditional probability is all about. We use a notation of P F and then read this. You write of course like a bar and you read it as P of F given that E has already occurred, and this is a conditional probability of F knowing that E has already occurred. What you saw also was that in the previous case it was 1 by 4. This 1 was nothing but the number of elements which were common to the set E and the set F, that is the common favorable for event E and event F. So, let us see if there is a relation that can be derived from here. I can rewrite from here probability of f given that E has happened same as number of elements in E intersection f divided by number of elements in the set E. Dividing both the numerator denominator by the total number of elements in the sample space, I get the entire numerator same as the probability of E intersection f, that is probability of E and f happening together divided by probability of E. And this gives us a formula for finding the probability of f given that E has occurred. It is same as probability of E intersection f divided by probability of E. If you know each one of them independently, take the quotient and you have the required quantity. If I take, of course, the condition of E is there, that probability of E should not be 0. The moment I write something in denominator, one has to pay attention to this, and that would mean that E is not an empty set. So, the things are meaningful only when E is not an impossible event. Similarly, probability of E given that f has happened will be probability of E intersection f divided by probability f. Condition on f remains the same, that is probability of f is a non-zero number, that is f is not an empty set. And with this we have a relation, a formula ready to be used. As in our previous case, you may go without this formula, just use the understanding and identify the number of elements that are common between the set E and f, that is the favorable which are common to event E, event f, and use that idea independent of this formula. Let us try an interesting and a simple problem. The problem says that mother, father and daughter line up at random for a family picture. If E is the event, daughter on one end, f father in middle, find probability of E given that f has happened. So, if I have three persons, mother, father and daughter, which I can represent as M, F and D, lining up, it basically is permutation of M, F and D, and there are 6 ways that they can be lined up. Now, we are given that the father is in middle, right. So, that means these are the only 2 possibilities that have been known to have occurred. Out of this, what are the cases where daughter appears on one end? Well, trivially, both are the cases, daughter could be on the left or on the right side of father, and therefore, in this case you do not need any formula, it is a sure event. So, E is going to happen if f has been known to be true, and therefore, probability of E given that f has occurred is trivially going to be equal to 1. So, things are interesting, sound to begin with a little baffling, but there is actually not much to do in this. Let us consider another application of conditional probability. The question says, given that the 2 numbers appearing on throwing 2 dice are different, find the probability of the event, the sum of numbers on dice is 4. The numbers appearing on throwing of 2 dice are different, means non-doublets are appearing. So, if I start with event E to be 2 numbers appearing on 2 dice are different and f as the event sum of numbers on dice is 4, then I need to find the probability of f given that E has happened. E non-doublets, 30 such cases. So, the number of elements in set E would be 30. F as I represent in the roster form, sum of numbers on dice is 4. There are only 3 possible outcomes. Out of these 3, how many would happen if E is known to have occurred? Obviously, just 2, 1 3, 3 1, and therefore, the probability of f given that E has occurred can be written as probability of E and f divided by probability of E, which is same as There are two elements which are common. So, 2 by 36 divided by 30 by 36, and therefore, 1 by 15. If you had thought of this answer directly, considering 2 out of 30 are the possible favorable for f, then that also would be absolutely correct. You can directly write probability of f given that E has happened to be 2 by 30, which is same as 1 by 15. So, we have the answer for this, which, as is expected of you, need to be stated in words at the end of the problem, because E, F or X, Y are our assumptions. So, you must conclude your statement in words. Let us consider one more application of conditional probability. The problem states that two integers are selected at random from integers 1 to 11. If the sum of integers chosen is even, find the probability that both numbers are odd. So, let us begin by defining the event E and F. E, the sum of integers is even, F, both numbers are odd. Then, as per the formula, probability of f given that E has occurred is same as probability of E and F divided by probability of E. In this case, we are looking at probability of E to be same as 6 C2 plus 5 C2 by 11 C2. This has come from an understanding that sum is even when both selected numbers are either odd or both are even. So, we have 6 odd, 5 even numbers, and therefore, 2 selected out of 6 can be done in 6C2 and 2 out of 5 can be selected in 5C2 ways. And therefore, the probability of E can be calculated as per this. Similarly, probability of E intersection F, out of 6 numbers 2 can be selected in 6C2 ways, and the total number of possible outcomes remains 11C2. Therefore, probability of F given that E has occurred by the formula would be probability of E and F divided by probability of E. Now, it is just simple calculation knowing what NCR is, and it results in 3 by 5 as your answer. So, the probability that both numbers are odd given that sum is even is 3 by 5. So, this was all about conditional probability. Given one event has occurred, what is the probability of another event happening in a certain experiment? In our next lesson, we will talk about will the probability of the second event get affected by knowing that something has already occurred? That will be discussed as our next lesson. See you.